Okay, back again. Sorry, I just realized that the I already recorded for 20 minutes. So before this, I realized that after 20 minutes, the recording is a bit like glitch. Has some glitch. Um, when I talk, it's not the same as the video goes. So I'll stop for the 20 minutes and I continue here. So now back to our example here for 2a. Okay, so the function is from -1 to 5. The range is from -1 to 5. We want to integrate 1 plus w times 2w plus w squared to the power 5 dw. So this is quite easy, right? So we substitute it and converted the limits, okay, as u is equals to 2w plus w squared, and you'll get du is equals to 2 plus 2w dw, and you'll get du over 2 is equals to 1 plus w dw after you factorize this, right? And then don't forget to change the range here, and you'll get when w is equals to -1, you'll get u is equals to -1. When w is equals to 5, you'll get u is equals to 35, right? Don't ask me how, you just substitute here lah, you'll get the answer, right? Okay, so now with your new range, and you get half to and then times integration of -1 to 35 u to the power 5 du. So it's quite easy to complete this and you get this answer. Okay, this is easy, I told you. Alright, so as this example, okay, the range is from -2 to -6, okay. We want to integrate 4 divided by 1 plus 2x to the power of 3 minus 5, 1 divided by 1 plus 2x dx. So here in this case, we let u is equals to 1 plus 2x, right? And du is equals to 2x, and dx is equals to half du. And then we substitute x with u, okay? When x is equals to -u, s is equal to -2, you'll get u is equals to -3, and when x is equals to -6, you'll get u to the equals to -11. So then you substitute it back, right? And then you take out half because it is a constant, and then you get an integration of -3 to -11 for u to the power of -3 minus 5 over u du. Then complete the integration as usual, and then you'll get half times -2 u to the power of -2 minus 5 ln u, where the range is -3 and to -11. And then put all the range inside the equation, and at the end of the day you'll get 112 divided by 1089 minus 5 over 2 ln 11 plus 5 over 2 ln 3. Okay, student? Alright. So C, okay, as C is quite lengthy a bit, but I guess you can complete this as easy peasy, right? So this is an integration from 0 to half e to the power of y plus 2 cos pi y dy. Alright, now, alright, you extract it. Alright, you extract the function where you can get for ey dy is 1 plus 0 half 2 cos pi y dy. Okay, alright, alright. And then you get you put u as equals to pi y, so du is equals to pi dy, so dy is equals to 1 over pi du, right? So don't forget to substitute the range. When y is equals to 0, u is equals to 0, but when y is equals to half, u is equals to pi over 2, right? So now the ey dy part, you complete it as usual, but this cos part, you need to use the substitution method. So the take note on the limit of the ey is the same, right? But the limit for the cos is different because you use the cos u du. Okay, so substitute as usual, you get cos u 2 over pi integration from 0 to pi over 2 cos u du. Alright, so the integration of cos u is sin u, so put the sign u here as the range from 0 to pi over 2, and then complete it one by one. You'll get e to the power of half minus 1 minus 2 over pi. Okay? Okay, you need to complete this lah. 2 over pi sine pi over 2 is what? Okay? And negative 2 pi sine times 0 is what? Okay, student? Okay. So, okay. So that's all for the example, exercise of 2. I got this one is 2. Before is exercise 1 or example 1. So from there, from the exercise 1, I need you to do the last question, which is 1E. So for exercise 2, I need you to do exercise 2D. If you watch this video, you know which question you want to answer. You need to answer and you need to submit it to me. You will know. Okay, so please watch this video. Okay, so please give me again, I repeat, please give me, please submit to me in the WhatsApp, just like last week, right? From exercise or example 1, E, and exercise 2, this one, D. Okay, student. Oh, okay, so we continue. So this is my whole point. All right, so this is the integration for trigonometric function. All right, so where negative sine x dx, negative cos x sine x, blah 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 blah. Okay, so I'm not going to read this to you, right? You can read it by yourself, right? So this is the exponential and algorithm function, and this one is the inverse trigonometric and hyperbolic function. If you want to find how to integrate this function, to prove by derivation, sorry, not by derivation, okay, by derive, okay. You can, I'll share you probably on Thursday, an YouTube link for you to maybe have a look or watch to understand further, all right, to understand further how to get the answer, okay, to get this answer, right? Okay. So anyway, you can use this to answer questions that I give you in this lecture, right? All right. See, we have another example from A to F, but this one is easy, okay? And then I guess this video will last. If you watch this video, it won't take you 2 hours. Probably take you the longest 40 minutes or 45 minutes, right? This is usual, because in physical class, right, I will show you in front of the whiteboard, and then it take time for me to write, and then took another few minutes if I ask you to complete the question, and then I will walk and have a look at one by one of your answers. Yeah, I usually do that in my class, right? If you sit at the back of my class, don't worry, I will go to you, okay? Right? So because this is on an online class, and then when I do my class, when we have a synchronous lecture, okay, using Zoom or WebEx, sometimes some of you told me that you have a very poor connection, so I understand that. And then some of you have a good connection. Sometimes you use Unify, but still you don't want to switch on your camera. So I feel that I'm talking alone, just like now. So might as well I recorded this lecture, and then I upload it, all right, earlier. So it's just the same. If you have any question, like usual, I am very, I guess I'm very, I always respond to your question inside the group. Okay, so I guess this is quite easier for me to give you this type of interaction. Probably next week we have a synchronous class. Okay, actually this is not 100% asynchronous class. This is also half and half. I need to prepare this video as a synchronous class, and then we actually meet inside the WhatsApp because I am going to wait for you to answer the question that I gave you. Okay, so I talked too much about this. Never mind. But now please answer the question, this question, because this is quite easy. You can do it. This question, the first one, you can do it like 20 seconds perhaps. All right. So complete this. So now you have 1, 2, 3, 4, 5, 6, 7, 8. 8 questions to be completed by you at the end of this lecture, students. Okay. So now, what is this? So now this is normal. So we're going to have a look at the solution for this one. Okay. 2x to the power of 2, sorry, from 0, we want to integrate from 0 to 2 for 2x divided by x to the power of 2 minus 5 dx. Okay, so using the substitution method as well, and you get the answer as negative ln 5. Okay, if I'm talking too fast, or I'm not, because it's quite difficult to record this, to have a look at the camera and also at the slides. Never mind, don't worry. You can always take your time to read or to do revision on this slide, because the source is available on my Google Classroom and you can access it anywhere and anytime. Okay, so this is an example of integration of log a to the power of x. Okay, log a to the power of x, which is actually the ln x divided by ln a. So have a look at the example, right? Log 2x over x dx, okay, is actually 1 over ln 2 divided by ln x over x dx. Okay, this is actually being substituted inside here lah. Okay, as you can see. Okay, because 2 is the 2 is what? Ln 2 is constant. Ln 2 is constant, so you take out the ln 2. It's actually ln x over ln 2 lah. Okay, ln x over x times ln 2. But because ln 2, 1 over ln 2 is constant, so we can take it out from the integration. So now we need to integrate ln x over x dx. So we substitute u is equals to ln x, du is equals to 1 over x dx. So substitute it together and you get u squared over 2 plus c, right? So don't forget to substitute it back, you get this. So it's actually easy. Okay, when you first look at this question, probably you will be scared because, oh, why is it so difficult? I never see this. But take a deep breath and then remember that I have taught you in class using this formula, and then slow by slow try to do it. Try to complete this and find the solution. Okay. If you follow my video, watch my video, try to understand it, read or do revision with my slides, inshallah, you will understand my lecture. It's as easy as that. Okay. So this is an integration by parts, students, right? So integration by parts is a technique for simplifying integrals of the form fx gx dx. It is very useful when f can be differentiated repeatedly and g can be integrated repeatedly without difficulty. So the integrals x cos x, for example, the integrals x cos x dx and x squared times e to the power of x dx, it is actually things that you can I'll try to find. So this is the integration by parts formula. Okay, I'm not going to bore you with this because in the questions I'm not going to ask you please give me the derivation of the integration by parts of formula. No, so you need to memorize only this. Only this. You need to memorize only this. Okay, which is u integration of u dv is equals to uv minus integration of v du. Okay, so now example. How to find the integration of x cos x dx. Okay, so actually there are 4 choices available for u and dv in this example. The first one is let u is equals to 1 and dv is equals to x cos dx. Second one, let u is equals to x and dv is equals to cos x dx. The third one, let u is equals to x cos x and dv is equals to dx. And the fourth one, let u is equals to cos x and dv equals to x ds. So which one would you choose? Which one would you choose, right? So rule number 1, okay, this rule you must be you must be complied you must comply this rule in order for the integration by parts for you to use the integration by parts, because at the end of the day, if you don't comply this rule, you won't get the answer. Okay, so the rule 1 is dv must be simple to integrate without using integration by parts. Okay, includes dx must be simple to integrate. Okay, and u is the leftover part. All right, and then rule 2. Okay, you can choose u in this order, and then dv is the leftover part. Okay, which is you can choose logarithmic functions first, and then inverse trigonometrics, and then algebraic functions, trigonometric function, and the last one is exponential function. Okay, so macam ni lah, pilih yang mana yang atas sekali. Yang atas sekali yang paling penting sekali. Okay, dan yang paling bawah adalah yang kurang penting. Yang mana mai dulu, yang tu yang apa pilih. Okay, so I will show you how to complete this, right? Okay, hold on, I'm back. First. Okay, it's actually tiring, although you're talking alone. Asynchronous or synchronous class, both are tiring, more tiring than physical class. I would rather choose physical class. So please, students, doa and then put some high hope so that we can actually attend the physical class. We can go back to the campus soon, right? I just miss to have a physical class with you guys, because I want to I want to look at you guys lah. I want to know and understand you guys, and I want to actually see my students, right? It's not the same where some in Johor, some in Kelantan, some in Perak, some in Selangor. Okay? It's not the same. So please, I hope that this COVID won't the COVID won't be gone, but just hope that the vaccine will come in soon, and we can get it as soon as possible, and the class can resume soon lah. Okay, all right, student, let's continue, right? Sorry, I just don't know how to show here, but never mind. Let's try this one today. Okay, no, okay, never mind. So now, the first question is, all right, ln x dx. All right. So the formula is u dv is equals to uv minus v du. So now, okay, to complete this, you need to multiply ln x by 1, which is actually ln x lah, but because we want that one, okay, y, as you can see here, u is equals to ln x, dv is equals to dx, so du is equals to 1 over x dx, v is equals to x, hence we need I forgot to put dx here, never mind, we need the 1 lah. Okay, so now using the formula uv minus integral of v du, so you just put it lah, substitute it, ln u is equals to ln x, v is equals to x minus integral of x times 1 over x dx, and at the end of the day you get x ln x minus x plus c. Okay, this is quite easy actually, but you need to know how to do it. If not, you're not going to able to complete the question. Okay, as for b, okay, integration of x e to the power f squared dx, right? Now in this case, you take u is equals to x squared. Du is equals to 2x dx. X dx is equals to du over 2. So x e to the power x over squared dx is equals to e to the power of u du over 2. Okay? Which is actually half times e to the power of u du. You get half e to the power of u plus c. So this is the end answer. Okay, the end answer. Right? Okay, students. So I guess I'm going to stop it here for our lecture today. All right. Okay. There's another two question. If you notice this integration by parts, let me transition it first. All right. There's another two question which is C and D. So I will leave it here first. Okay. Why I'm going to leave this here, I will tell you soon. But never mind. Don't complete this question yet. Don't complete this question yet. But please complete the question that I told you before. Okay. Which question that you need to send to me at the end of this class is this one. Remember, I don't know what number slide of this, but you'll see the example. So we have 1, 2, 3, 4, 5, 6, 2, 4, 6, 6 questions. D, 7 questions. And E, okay, 8 questions. So please submit for me 8 questions at the end of this class. Okay, student. So that's all for today. I'm very happy that I can record this class today. Okay. So thank you very much for your time, and I hope you enjoy my class and lecture. If you have anything, if you don't understand anything in this topic, please ask me. Okay. Okay. In WhatsApp during our lecture, I try to answer for you as soon as possible. Okay. Other than that, don't ask me the answers for the question that I asked you to complete lah. It's not fair. Okay. So that's all, student. Thank you and Assalamualaikum, and have a very good day. Bye.